September 9, 1942. A small floatplane rose from the Pacific Ocean off the coast of Oregon. The pilot was Warrant Flying Officer Nobuo Fujita of the Imperial Japanese Navy. His mission: bomb the forests of the American mainland. This wasn't a carrier-based aircraft. It hadn't flown from a distant airfield. It had been launched from a submarine, the I-25, a submarine that carried its own aircraft in a waterproof hangar. Fujita flew east toward the Oregon coast in darkness. He carried two 76-kilogram incendiary bombs. His target: the forests near Brookings, Oregon. His goal: start massive forest fires that would burn uncontrollably. At 0600 hours, Fujita reached his target area. He dropped his bombs into the dense coastal forest. He turned and flew back to the waiting submarine. He had just conducted the only aerial bombing of the continental United States during World War II. The bombs landed in the wet forest. They failed to start the massive fires Japan had hoped for. A few small blazes were quickly extinguished by Forest Service crews. The damage was negligible. But the strategic implications were profound. Japan had demonstrated it could attack American soil directly. A submarine had launched an aircraft that bombed America. The psychological impact exceeded the physical damage. Fujita returned 6 days later for a second bombing run. Again, the bombs caused minimal damage, but the message was unmistakable. America was vulnerable to attack from unexpected directions. This was the culmination of years of Japanese naval innovation. Submarine-launched aircraft were a uniquely Japanese development. No other navy had successfully deployed this technology operationally. The concept seemed impossible, yet Japan had made it work. The I-25 was one of several Japanese submarines equipped with floatplanes. These submarines could surface, assemble their aircraft, launch attacks, recover the plane, and disappear beneath the waves. The capability gave submarines reconnaissance and attack range far beyond their torpedoes. But launching an air raid on America was never the primary purpose. The aircraft were designed for reconnaissance over enemy fleets. The Oregon bombing raids were improvised operations. Even Japanese command was surprised when they heard the mission succeeded. This is the story of the only aerial bombing of the continental United States in World War II. The story of Japanese submarine innovation that created a capability no other navy matched. The story of Nobuo Fujita, who bombed America and later returned as a friend, and the story of how technological innovation can succeed tactically while failing strategically. Historical context: the submarine that carried an aircraft. Japanese naval aviation was obsessed with extending aircraft range from the earliest days of military aviation. The vast Pacific Ocean demanded long-range capabilities that European navies never needed to the same degree. The distances between Japanese bases and potential enemies were enormous. Carrier aircraft could project power hundreds of miles beyond the fleet, but carriers were extremely valuable assets, vulnerable to attack and limited in number. Submarines offered stealth and surprise that carriers couldn't match. They could approach enemy positions undetected. They could operate independently without fleet support. But submarines were fundamentally limited to torpedo attacks and brief gun actions on the surface. Their inability to see beyond the horizon was a severe operational limitation. If a submarine could somehow carry an aircraft, it could combine stealth with aerial reconnaissance and potentially attack capabilities. The aircraft could scout far beyond the submarine's visual range of perhaps 10-12 miles. It could search hundreds of square miles of ocean for enemy ships. It could report enemy positions, courses, and compositions by radio. It could direct the submarine to favorable attack positions. This concept didn't originate with Japan, but Japan pursued it most aggressively. The idea emerged internationally in the 1920s, when both aircraft and submarines were maturing as military technologies. The British Navy conducted early experiments with submarine-launched aircraft in the 1920s. They fitted the submarine HMS M2 with a small hangar and catapult in 1925. The M2 could carry a Parnell Peto reconnaissance floatplane, but the system proved operationally impractical for several reasons. The aircraft was too small to be useful, assembly took too long, leaving the submarine vulnerable. British submarine doctrine emphasized stealth over complex operations. The M2 sank in an accident in 1932, partly due to hangar door problems. The British abandoned submarine-launched aircraft as too dangerous and impractical. The United States Navy also experimented with the concept in the 1920s. The submarine S-1 was fitted with a small cylindrical hangar in 1923. Tests demonstrated that while technically possible, the operational challenges were formidable. American naval doctrine emphasized using submarines for commerce raiding and fleet attacks. The additional complexity of aircraft operations didn't align with American submarine tactics. The US Navy abandoned the concept by the late 1920s, but Japan didn't abandon it. They doubled down on development. Japanese strategic thinking emphasized several factors that made submarine-launched aircraft attractive. Japan expected to fight a decisive fleet battle against the US Navy somewhere in the Western Pacific. Reconnaissance would be critical to finding and engaging the enemy fleet advantageously. Japan's geographic position required long-range operations across vast ocean areas. Submarine-launched aircraft could provide reconnaissance without risking valuable carriers. Japanese naval doctrine valued creative, unexpected tactics that could provide asymmetric advantages. Japanese engineering efforts began systematically in 1923 with basic experiments. By 1927, they had successfully launched aircraft from submarines using deck-mounted catapults. These early systems were crude. The aircraft sat exposed on deck, preventing the submarine from diving. Throughout the 1930s, Japanese engineers refined the concept persistently. They developed waterproof hangars that could be sealed to allow the submarine to dive. They miniaturized aircraft designs specifically for submarine operations. They created quick assembly mechanisms, allowing aircraft to be assembled rapidly on deck. They trained specialized crews in the complex procedures for launch and recovery. They developed doctrine for employing submarine-launched aircraft in reconnaissance and potentially attack roles. By 1941, Japan had successfully developed operational submarine-launched aircraft capability. No other navy had achieved this. The British and Americans had abandoned efforts. German and Italian navies never seriously pursued it. The I-class submarines carrying aircraft represented cutting-edge naval technology. Several submarine types were equipped with aircraft carrying capability. The B-1 type submarines, like the I-25, carried one Yokosuka E-14Y Glenn floatplane. The A-1 type submarines carried one aircraft in similar configurations. The later I-400 class submarines, commissioned 1944-1945, could carry 3 Aichi M6A Seiran bombers. The I-25 specifically was a B-1 type submarine commissioned in October 1941, just before Pearl Harbor. She represented the mature development of Japan's submarine-launched aircraft concept. Specifications demonstrated the engineering compromises required. Surface displacement, 2,584 tons, relatively large for submarines of the era. Submerged displacement, 3,654 tons. Length, 356.5 feet, 108.7 meters. Beam, 30.5 feet, 9.3 meters. Draft, 16.5 feet, 5.0 meters. Crew, 94 officers and men, larger than most submarines due to aircraft operations. The size and crew requirements were driven by the aircraft carrying capability. Traditional fleet submarines were smaller and had fewer crew. The I-25 sacrificed some diving depth and maneuverability for the aircraft capability. Maximum diving depth was approximately 330 feet, 100 meters. This was adequate for most operations, but not as deep as some American or German submarines. The large hangar structure limited structural strength for extreme depths. Surface speed was 23.5 knots maximum. Submerged speed was 8 knots maximum. Range was 14,000 nautical miles at 16 knots surfaced, exceptional range for any submarine. This range was essential for Pacific operations where distances were enormous. Armament included 6 530 Trium 21-inch torpedo tubes, 17 Type 95 torpedoes carried, one 140 meters of 5.5-inch deck gun for surface actions, two 25-meter anti-aircraft guns for air defense when surfaced, one Yokosuka E-14Y Glenn floatplane with two 76 kilos bombs or reconnaissance equipment. The torpedo armament was the submarine's primary weapon system. The aircraft was a secondary capability for reconnaissance and special missions. Japanese doctrine emphasized fleet attacks with torpedoes as the submarine's main purpose. The Yokosuka E-14Y Glenn floatplane was specifically designed for submarine operations. Glenn was the Allied code name. The Japanese designation was Type 0 Small Reconnaissance Seaplane. Development began in 1938 by Watanabe, later Kyushu, and Yokosuka Arsenal. First flight was in 1940. Operational deployment began in 1941, just before the war started. The E-14Y specifications reflected the extreme design constraints. Wingspan, 11.0 meters, 36.1 feet, when assembled. Length, 8.5 meters, 27.9 feet. Height, 3.6 meters, 11.8 feet on floats. Empty weight, 504 kilo, 111 pounds. Loaded weight, 150 kilo, 2,535 pounds. Maximum speed, 246 km/h, 153 mph. Slow even for 1940 standards. Cruise speed, 150 km/h, 93 mph. Range, 880 km, 548 miles, maximum. Service ceiling, 5,260 meters, 17,260 feet. Crew, pilot and observer John Gunner, 2 crew. Armament for the E-14Y was minimal, one flexible mounted 7.7mm machine gun in the rear cockpit for self-defense, up to 152 kilograms, 340 pounds, of bombs or depth charges for attack missions. Usually carried two 76 kilon, 167-pound bombs. The aircraft was underpowered and lightly built, reflecting the need for low weight to fit in the submarine hangar. It couldn't defend itself effectively against enemy fighters. Its slow speed made it vulnerable to interception. Its role was reconnaissance and surprise attacks, not air combat. The cylindrical waterproof hangar built into the I-25's conning tower area was an engineering marvel. Dimensions: 3.5 meters, 11.5 feet diameter, 11.3 meters, 37 feet long. This barely accommodated the disassembled E-14Y with wings, floats and tail removed. The hangar was positioned just forward of the conning tower. It was integrated into the pressure hull with specially reinforced structure. The hangar door was a curved hatch that swung upward and forward on hinges. Multiple locking mechanisms secured it during diving. Rubber gaskets and seals ensured watertightness. The hangar could withstand pressure at the submarine's maximum diving depth. Inside the hangar, the disassembled aircraft components were secured with custom brackets. The fuselage was mounted on a wheeled dolly that could roll out onto the deck. Wings were secured along the sides of the fuselage. Floats were stacked and secured separately. The horizontal stabilizer and tail assembly were stored in specific locations. Tools, spare parts, and the aircraft's bombs were also stored within the hangar. A small crane, mounted on the submarine's deck, could lift the aircraft for recovery after missions. The crane could handle approximately 1,500 kilograms, 300 pounds. It could lift the empty or lightly loaded E-14Y from the water onto the deck for disassembly. The catapult was a compressed air system rather than gunpowder or hydraulic. Compressed air systems were safer for submarine operations. They didn't produce flames or dangerous exhaust gases. They could be maintained more easily in the confined submarine environment. Air compressors within the submarine maintained pressure in storage tanks. The catapult could launch the aircraft using stored compressed air without running compressors during launch. This maintained stealth. The launch itself was relatively quiet compared to gunpowder catapults. Launch procedure was complex and time-critical. The submarine surfaced in a safe location, ideally at night or in poor visibility. The hangar door was opened and the aircraft dolly was rolled out onto the deck. Crew assembled the aircraft, attached wings, 4 attachment points with quick-release pins, installed floats, 2 per aircraft with strut connections, attached horizontal stabilizer and tail surfaces. The engine was started and warmed up while still on the catapult. The pilot and observer boarded and performed pre-flight checks. Bombs or reconnaissance equipment were loaded. The catapult was charged with compressed air. At the pilot's signal, the catapult operator launched the aircraft. Total time: 20-30 minutes for experienced crews under good conditions, longer in rough seas or poor weather. During this entire process, the submarine was extremely vulnerable. It couldn't dive quickly with the aircraft on deck and hangar open. It had limited maneuverability with the aircraft assembly process ongoing. It was visible to aircraft and ships from long distances. Enemy aircraft could attack before the submarine could defend itself or dive. Rough seas could make assembly dangerous or impossible. Recovery was equally complex and dangerous. The aircraft would land on the ocean surface near the submarine. The pilot would taxi as close as possible without risking collision. Crew would throw lines to secure the aircraft. The aircraft would be partially disassembled on the water, remove wings, floats. The crane would lift the aircraft fuselage onto the deck. Components would be stowed in the hangar. The hangar would be sealed. The submarine could then dive. Total time: 30 to 45 minutes under good conditions. Both launch and recovery required relatively calm seas. In rough conditions, operations became extremely dangerous or impossible. This weather dependency limited operational flexibility. Despite these challenges, Japan successfully deployed submarine-launched aircraft operationally. They provided valuable reconnaissance during several naval operations. They scouted enemy positions before major engagements. They searched vast ocean areas for enemy fleets. But the utility was limited by the same factors that had caused Britain and America to abandon the concept: the operational complexity and danger, the vulnerability during launch and recovery, the limited capability of the aircraft themselves, the relatively small contribution compared to the resources required. Japan's persistence with submarine-launched aircraft reflected their strategic desperation and tactical creativity. They needed advantages to offset America's superior industrial capacity. They pursued innovative technologies, hoping to find asymmetric capabilities. Submarine-launched aircraft seemed to offer such capability. But, as the Oregon bombing raids would demonstrate, innovation without strategic purpose achieves little. The I-25 was a B-1 type submarine commissioned in October 1941. She displaced 2,584 tons surfaced and 3,754 tons submerged. She was 356 feet long with a crew of 94. She could cruise 14,000 nautical miles at 16 knots surfaced. Her armament included 6 530-Newton torpedo tubes, 17 torpedoes carried, 1 140-meter deck gun, 2 25-meter anti-aircraft guns, 1 Yokosuka E-14Y Glenn floatplane. The floatplane was the key to her unique capability. The Yokosuka E-14Y was a small reconnaissance seaplane designed specifically for submarine operations. It had a wingspan of 11 meters and length of 8.5 meters. It was powered by a single 340 horsepower radial engine. Maximum speed was 153 meters with a range of 548 miles. The aircraft was stored in a cylindrical hangar built into the submarine's conning tower. The hangar was 3.5 meters in diameter and 11 meters long. It could store the aircraft with wings and floats detached. The hangar was watertight, essential for diving. To launch the aircraft, the submarine followed a precise procedure. Surface in safe location, preferably at night. Open the hangar and remove the disassembled aircraft. Assemble the aircraft on deck. Attach wings, floats, tail assembly. Install the bombs or reconnaissance equipment. Fuel the aircraft from submarine's tanks. Launch from a compressed air catapult mounted on deck. The entire process took approximately 30 to 40 minutes with a trained crew. During this time, the submarine was vulnerable. It couldn't dive quickly with the aircraft on deck. Enemy aircraft or ships could attack during the launch process. Recovery was equally complex. The floatplane would land in the water near the submarine. Crew would secure the aircraft with lines. The aircraft would be partially disassembled, remove wings and floats. It would be hoisted back into the hangar using a crane. The hangar would be sealed. The submarine could then dive. Recovery took 30 to 45 minutes. Again, the submarine was extremely vulnerable during this process. Despite these risks, the capability was valuable for reconnaissance. A submarine could approach an enemy fleet position, launch its aircraft for observation. The aircraft could scout far beyond the submarine's visual range. It could report enemy ship types, numbers, positions, and courses. This information was transmitted by radio to Japanese command. The submarine's ability to launch surprise attacks was limited by the aircraft's capabilities. The E-14Y carried only two 76-kilogram bombs, about 340 pounds total. This was insufficient to seriously damage warships. It could harass merchant shipping or conduct reconnaissance. But it wasn't a significant offensive weapon against naval targets. Japanese doctrine emphasized reconnaissance over attack for these aircraft, but doctrine didn't prevent innovative commanders from attempting creative missions. Commander Meiji Tagami commanded the I-25. He was an experienced submarine officer with aggressive instincts. After the Pearl Harbor attack, the I-25 operated along the American west coast. She conducted reconnaissance and sank two merchant ships with torpedoes. By September 1942, Japan's strategic situation was deteriorating. The Doolittle raid on Tokyo in April 1942 had shocked Japan. American bombers had attacked the Japanese homeland. Japan wanted to retaliate, to show America was also vulnerable. Tagami proposed using the I-25's aircraft to bomb American forests. The US West Coast had vast forest areas that were dry in late summer. Incendiary bombs could potentially start massive forest fires. These fires would divert American resources and create psychological impact. Japanese Naval Command approved the mission. It was unprecedented, using submarine-launched aircraft to bomb the American mainland. No one knew if it would work, but the psychological value of attacking American soil justified the risk. The target selected was the Oregon coast near Brookings. This area had extensive forests close to the coastline. Weather patterns and terrain suggested fires could spread uncontrollably. The forests provided lumber for the American war effort. Destroying them would have economic impact. Warrant Flying Officer Nobuo Fujita was the I-25's pilot. He had extensive experience with submarine-launched operations. He would fly both bombing missions. The strategic context was crucial. By September 1942, Japan's offensive momentum had stalled. Midway had been a devastating defeat in June. Guadalcanal was becoming a grinding battle of attrition. Japan needed morale victories. Bombing America provided such a victory, if it succeeded. Allied intelligence knew about Japanese submarine-launched aircraft, but they didn't know Japanese planned to use them against the mainland. The possibility had been considered, but deemed unlikely. Submarines were more valuable for attacking ships. Using them for minor bombing raids seemed wasteful. But Japan was thinking differently. They saw psychological warfare value that outweighed tactical limitations. Technical analysis, engineering the impossible. The Yokosuka E-14Y Glenn floatplane represented remarkable engineering for its era. Designing an aircraft to be stored inside a submarine required solving unprecedented challenges. First challenge, fitting a functional aircraft into a 3.5-meter diameter cylinder. The E-14Y had to be small enough to fit when disassembled, but large enough to carry useful payload and have adequate range. The design solution was modular construction. The aircraft was built in sections that could be quickly attached and detached. The wings were removable at the fuselage attachment points. The horizontal stabilizers detached from the vertical stabilizer. The two floats could be removed from their attachment struts. Quick-release mechanisms allowed these components to separate without tools. Pins and locks secured components during assembly. A trained crew could assemble the aircraft in 20–25 minutes. Disassembly took 15 to 20 minutes. The aircraft structure had to be lightweight, yet strong enough for catapult launch. Catapult launch imposed severe acceleration forces. The airframe had to withstand approximately 3 to 4 G forces during launch. Traditional aircraft construction wasn't designed for these stresses. Japanese engineers used a mixed construction technique: steel tube frame for primary structure, fabric covering for most surfaces, aluminum for critical stressed components, wood for non-structural fairings. This combination provided strength with minimal weight. The empty weight was only 1,111 pounds. Maximum takeoff weight was 2,535 pounds. The power-to-weight ratio was adequate for carrier operations from the catapult. The catapult system was equally impressive. It used compressed air stored in tanks within the submarine. The aircraft sat on a cradle attached to a piston. When fired, compressed air drove the piston along a track. The aircraft accelerated from 0 to approximately 60 meps in 70 feet. This acceleration was violent. Pilots experienced significant G-forces during launch. The aircraft had to achieve flying speed almost instantly. If the catapult malfunctioned, the aircraft would fall into the water before gaining flight. Pilots couldn't control the aircraft during catapult launch. They had to trust the catapult operator's timing and the catapult's reliability. Once launched, the pilot had only seconds to establish controlled flight. The floats were specially designed for submarine operations. Traditional seaplane floats were large and created significant drag. The E-14Y's floats were streamlined for minimum drag, but they had to be large enough to support the aircraft's weight on water. The floats could be pressurized